Okay friends, welcome back. So let's start chapter 6, that is landforms and the revolution. After weathering processes have had their actions on the earth materials making up the surface of the earth. The geomorphic agents like running water, groundwater, wind, glaciers, waves perform erosion. It is already known to you that erosion causes changes on the surface of the earth. Deposition follows erosion, and because of deposition, too, changes occur on the surface of the earth. As this chapter deals with landforms and the revolution, first start with the question, what is a landform? In simple words, small to medium tracts or parcels of the earth's surface are called landforms. Parcels of the earth's surface are called landforms. Okay, if a landform is a small to medium sized part of the surface of the earth, what is a landscape? So definitely it is the bigger one. Several related landforms together make up landscape. Yes, large tracts of earth's surface. Each landform has its own physical shape, size, materials, and is result of the action of certain geomorphic processes and agents. Actions of most of the geomorphic processes and agents are slow, and hence the results take a long time to take shape. Every landform has a beginning. Landforms once formed many change in their shape, size and nature, slowly or fast due to continued action of geomorphic processes and agents. Due to changes in climatic conditions and vertical or horizontal movements of land masses, either the intensity of processes or the processes themselves might change, leading to new modifications in the landforms. Evolution here implies stages of formation, stages of transformation of either a part of the earth's surface from one landform into another, or transformation of individual landforms after they are once formed. That means each and every landform has a history of development and changes through time. A land mass passes through stages of development somewhat comparable to the stages of life, youth, mature, and old age. What are the two important aspects of the evolution of landforms? Now, running water. In humid regions which receive heavy rainfall, running water is considered the most important of the geomorphic agents in bringing about the degradation of the land surface. There are two components of running water. One is overland flow on general land surface as a sheet. Another is linear flow as streams and rivers in valleys. Most of the erosional landforms made by running water are associated with vigorous and youthful rivers flowing over steep gradients. With time, stream channels over steep gradients turn gentler due to continued erosion, and as a consequence lose their velocity, facilitating active deposition. There may be depositional forms associated with streams flowing over steep slopes, but these phenomena will be on a small scale compared to those associated with rivers flowing over medium to gentle slopes. The gentler the river channels in gradient of slope or slope, the greater is the deposition. When the stream beds turn gentler due to continued erosion, downward cutting becomes less dominant and lateral erosion of banks increases, and as a consequence the hills and valleys are reduced to plains. Is complete reduction of belief of a high landmass possible? मतलब क्या हिमालय पूरी तरह से खाए हो सकते हैं? ओवरलैंड फ्लो causes sheet erosion depending upon irregularities of the land surface. The overland flow may concentrate into narrow to wide paths because of the shear friction of the column of flowing water. Minor or major quantities of materials from the surface of the land are removed in the direction of flow, and gradually small and narrow rills will form. These rills will gradually develop into long and wide gullies. The gullies will further deepen, widen, lengthen, and unite to give rise to a network of valleys. In the early stages, downcutting dominates, during which irregularities such as waterfalls and cascades will be removed. In the middle stages, streams cut their beds slower, and the lateral erosion of valley sides becomes severe. Gradually, the valley sides are reduced to lower and lower slopes. The divides between drainage basins are likewise lowered until they are almost completely flattened, leaving finally a lowland of faint relief with some low resistant remnants called monadnock standing out here and there. This type of plain forming as a result of stream erosion is called a peneplain, an almost plain. The characteristics of each of these stages of landscape developing in running water regimes may be summarized as follows. राइट, तो पेनीप्लेन का कॉन्सेप्ट किसने दिया था, मोनाडनॉक का कॉन्सेप्ट किसने दिया था, ये भी इम्पोर्टेंट सवाल आपका बनेगा. नाउ यूथ स्टेज पे आते हैं. स्ट्रीम्स आर फ्यू ड्यूरिंग दिस स्टेज विथ पुअर इंटीग्रेशन एंड फ्लो ओवर ओरिजिनल स्लोप शोइंग शैलो वी शेप्ड वैलीज विथ नो फ्लैट प्लेन्स और विथ वेरी नैरो फ्लैट प्लेन्स अलोंग ट्रंक स्ट्रीम्स. Streams divides are broad and flat with marshes, swamp and lakes. Meanders if present develop over these broad upland surfaces. These meanders may eventually outrange themselves into the uplands. Waterfalls and rapids may exist where local hard rock bodies are exposed. मैच्योर स्टेज में क्या होगा? ड्यूरिंग दिस स्टेज स्ट्रीम्स आर प्लेंटी विथ गुड इंटीग्रेशन. द वैलीज आर स्टिल वी शेप्ड but deep. Trunk streams are broad enough to have wider flat plains within which streams may flow in meanders confined within the valley. The flat and broad interstreams areas and swamps and marshes of youth disappear and the streams divides turn shape. Waterfalls and rapids disappear. तो मैच्योर स्टेज में वाटरफॉल्स एंड रैपिड जो है वो डिसअपियर हो जाता है. यही बात एटलीस्ट याद रखो. नाउ ओल्ड स्टेज में आता है तो स्मॉलर ट्रिब्यूटरीज ड्यूरिंग ओल्ड एज आर फ्यू विथ gentle gradients. Streams meander freely over vast floodplains showing natural levees, oxbow lakes, etc. Divides are broad and flat with lakes, swamps and marshes. Most of the landscape is at or slightly above sea level. एक बात यहाँ पर नोट करने वाली यह था कि यूथ स्टेज में क्या हो रहा है. देखो स्ट्रीम्स आर वेरी फ्यू ड्यूरिंग द स्टेज विथ पुअर इंटीग्रेशन फ्लो ओवर ओरिजिनल स्लोप शोइंग शैलो वी शेप वैलीज विथ नो फ्लैट प्लेन्स और विथ वेरी नैरो फ्लैट प्लेन्स अलोंग ट्रंक स्ट्रीम्स. स्ट्रीम्स डिवाइड्स आर ब्रॉड एंड फ्लैट विथ मार्शेस, स्वैम्प एंड लेक्स. meanders if present develop over these broad upland areas. मतलब यूथ स्टेज में भी meander हो सकता है और फिर जैसे स्टार्ट होता है वैसे ही ख़त्म हो जाता है. इसलिए रिवर को मतलब हमारा जो लाइफ है या फिर रिवर का जो डेविस ने जो कंपेयर किया था वो लाइफ के साथ किया था. यूथ, मैच्योरिटी एंड ओल्ड. ओके. इरोशनल लैंडफॉर्म्स. वैलीज स्टार्ट एज स्मॉल एंड नैरो रील्स. द रील्स विल ग्रेजुअली डेवलप इनटू लॉन्ग एंड wide gullies. The gullies will further deepen, widen and lengthen to give rise to valleys. Depending upon dimensions and shape, many types of valleys like V-shape, valley, gorge, canyon, etc. can be recognized. A gorge is a deep valley with very steep to straight sides, and a canyon is characterized by steep step-like side slope. तो step होता है step like side slope कहाँ होता है? कैनियन में होता है step like side slopes होता है and may be as deep as a gorge. A gorge is almost equal in width as its top as well as its bottom. In contrast, a canyon is wider at its top than at its bottom. तो ये डिफरेंस जो है, ये जो नया इन्फॉर्मेशन था स्टेप लाइक साइड स्लोप्स के, ये मतलब गॉर्जेस एंड कैनियन का जो डिफरेंस है काफ़ी इंपॉर्टेंट है. बट ये स्टेप लाइक साइड स्लोप्स होता है और जो गॉर्जेस का जो साइड्स है वो वेरी स्टीप टू स्ट्रेट साइड्स होता है. तो ये भी एक है. इनफैक्ट ए कैनियन इज a variant of gorge. Valley types depend on the type and structure of rocks in which they form. For example, canyons commonly form in horizontal bedded sedimentary rocks and gorges form in hard rocks. Okay, so horizontal bedded sedimentary rocks, तो canyons form in sedimentary rocks and gorges form in hard rocks. ये भी एक important definition है. बट यहाँ पर एक चीज़ मिस हो गया जो हर बुक में लिखा रहता है, मतलब जो पढ़ के आए हैं वो ये है कि जो गॉर्जेस है वो वी शेप्ड है, कैनियन जो है वो आई शेप्ड है, और गॉर्जेस जो है वो जहाँ पर बारिश ज़्यादा होती है माउंटेनस एरियाज में वहाँ पर बनता है, और जो कैनियन है वो एरिड एरियाज में बनता है. बट उसका मेंशन तो कुछ है ही नहीं, मतलब मैंने गलत पढ़ के आए हैं क्या, तो बताना ये कमेंट करके. नाउ पॉटहोल्स एंड प्लांच पूल्स. ओवर द रॉकी बेड्स ऑफ हिल स्ट्रीम्स more or less circular depressions called potholes form because of stream erosion aided by the abrasion of rock fragments. Once a small and देखो गॉर्ज दिखाया गया है, यहाँ पर कैनियन दिखाया गया है. ठीक है, तो इसको हम कैनियन बोलते हैं. बट ये तो मियंडर है भाई. अच्छा, एन एंट्रेंस्ड मेंडर लिखा हुआ है. लूप ऑफ रिवर कंटिन्यूअसली शोइंग स्टेप लाइक साइड स्लोप्स ऑफ इट्स वैली टिपिकल ऑफ ए कैनियन. कैनियन में भी ऐसा होता है, ये बोलना चाहते हैं. बाय द वे क्या कहाँ पर रहे थे हम, यहाँ पर क्या था, potholes plant pool. So once a small and shallow depression forms, pebbles and boulders get collected in those depressions and get rotated by flowing water, and consequently the depressions grow in dimensions. A series of such depressions eventually join and the stream valley gets deepened. At the foot of Waterfalls also large potholes quite deep and wide form because of the sheer impact of water and rotation of boulders. Such large and deep holes at the base of waterfall are called plunge pools. Now, incised or entrenched meanders in streams that flow rapidly over steep gradients, normally erosion is concentrated on the bottom of the stream channel. Also, in the case of steep gradient streams, lateral erosion on the sides of the valleys is not much when compared to the streams flowing on low and gentle slopes. Because of active lateral erosion, streams flowing over gentle slopes develop sinus or meandering courses. It is common to find meandering courses over flat plains and delta plains where stream gradients are very gentle, but very deep and wide meanders can also be found caught in hard rocks. सच meanders are called incised और entrenched meanders. तो एक्चुअल जो डेफिनेशन है वो इतना सा है कि जब वेरी डीप एंड हार्ड वेरी डीप meanders हम फाउंड करते हैं, ठीक है, वेरी डीप एंड वाइड meanders कैन ऑल्सो बी फाउंड कट इन हार्ड रॉक्स, तो उसको हम बोलते हैं इंसाइज्ड और एंट्रेंच्ड meanders. बाकी तो देखने में सेम है, बट वो हार्ड रॉक में बनता है और कट करता है, ठीक है, रिवर बेड को. नाउ रिवर ट्रेसेस आर सर्फेसेस मेकिंग ओल्ड वैली फ्लोर और फ्लैट प्लेन लेवल्स. They may be bedrock surfaces without an alluvial cover or alluvial traces consisting of stream deposits. River traces are basically products of erosion as they result due to vertical erosion by the stream into its own depositional floodplain. There can be a number of such traces at different heights indicating former riverbed levels. The river traces may occur at the same elevation on either side of the rivers, in which case they are called paired traces. Okay. पेयर ट्रेस मतलब दोनों साइड में आपका रिवर ट्रेस बन जाता है, तो तब आपको पेयर ट्रेस बोला जाएगा. नाउ डिपोजिशनल लैंडफॉर्म्स. एलुवियल फैंस आर फॉर्म्ड व्हेन स्ट्रीम्स फ्लोइंग फ्रॉम हायर लेवल्स ब्रेक इनटू फुट स्लोप प्लेन्स ऑफ लो ग्रेडियंट. नॉर्मली वेरी कोर्स लोड इज कैरिड बाय स्ट्रीम्स फ्लोइंग ओवर माउंटेन स्लोप्स. दिस लोड becomes too heavy for the streams to be carried over gentler gradients and gets dumped and spread as a broad low to high cone shaped deposit called alluvial fan. Usually the streams which flow over fans are not confined to their original channels for long and shift their position across the fans, forming many channels called distributaries. Alluvial fans in humid areas show normally low cones with gentle slope from head to toe, and they appear as high cones with steep slope in arid and semi-arid climate. Now deltas are like alluvial fans but develop at a different location. The load carried by the river is dumped in and spread into the sea. If this load is not carried away far into the sea or distributed along the coast, it spreads and accumulates as a low cone. Unlike in alluvial fans, the deposits making up deltas are very well sorted with clear stratification. The coarsest materials settle out first, and the finer fractions like silts and clays are carried out into the sea. As the delta grows, the river distributaries continue to increase in length, and delta continues to build up into the sea. Flat plains, natural levees, and point bars. So this deposition develops a flat plain just as erosion makes valleys. Flat plain is a major landform of river deposition. Large sized materials are deposited first when stream channels breaks into gentle slope. Thus normally fine sized materials like sand, silt and clay are carried by relatively slow moving waters in gentler channels usually found in the plains and deposited over the bed, and when the waters spill over the banks during flooding above the bed. A riverbed made of river deposits is the active flood plain. A riverbed made of river deposits is the active flood plain. The flood plain above the bank is inactive flood plain. Okay. Inactive flood plain above the banks basically contain two types of deposits, that is flood deposits and channel deposits. In plains, channels shift laterally and change their courses, occasionally leaving cut-off courses which get filled up gradually. Such areas over flood plains built up by abandoned or cut-off channels contain coarse deposits. The flood deposits of spilled waters carry relatively finer materials like silt and clay. The flood plains in a delta are called delta plains. जो है दिखाया गया है पॉइंट बार्स क्या है, नेचुरल लिवी क्या है, फ्लड प्लेन क्या है. तो ये पॉइंट बार्स और जो नेचुरल लिवी है ये किसके थ्रू बनता है, डिपोजिशन ऑफ रिवर्स. ठीक है, डिपोजिशन ऑफ रिवर्स के थ्रू बनता है. ये जो फीचर है याद रखना, पॉइंट बार्स एंड नेचुरल लिवी. ओके. Now, natural levees and point bars are some of the important landforms found associated with flood plains. So, natural levees are found along the banks of a large river They are low, linear and parallel ridges of coarse deposits along the banks of rivers, quite often cut into individual mounds. Point bars are also known as meander bars. They are, so the point bars are also known as meander bars, right? They are found on the concave side of meanders of large rivers and are sediments deposited in a linear fashion by flowing waters along the bank. They are almost uniform in profile and in width and contain mixed size of sediments. In what way do natural leaves differ from point bars? Yes, this is an important concept कि in what way do natural leaves differ from the point bars. तो आप पिक्चर देखना है तो इसमें देखो पॉइंट बार और नेचुरल लीव्स में क्या डिफरेंस है, ठीक है। Point bars are also known as meanders. They are found on the concave side of meanders of large rivers and are sediments deposited in a linear fashion by flowing waters along the bank. तो दिया हुआ है सारा चीज़, तो वहाँ से आप डिराइव कर सकते हो इन्फॉर्मेशन और लिख सकते हो। They are almost uniform in profile and in width and contain mixed size of sediments. Okay, meanders in large flood and delta plains. Rivers rarely flow in straight courses. Loop-like channel patterns called meanders develop over flood and delta plains. Meander is not a landform but is only a type of channel pattern. Okay, देखो यहाँ पर क्या लिखा गया है कि meander is not a landform but is only a type of channel pattern. This is because of propensity of water flowing over very gentle gradients to work laterally on the banks, unconsolidated nature of alluvial deposits making up the banks with many irregularities which can be used by water exerting pressure laterally. Coriolis force acting on the fluid water, deflecting it like it deflects the wind. When the gradient of the channel becomes extremely low, water flows leisurely and starts working laterally. Slight irregularities along the banks slowly get transformed into a small curvature in the banks. The curvature depends due to deposition on the inside of the curvature of the curve and erosion along the bank on the outside. If there is no deposition and no erosion or undercutting, the tendency to meander is reduced. Normally in meanders of large rivers, there is active deposition along the concave bank and undercutting along the convex bank. The concave bank is known as cut-off bank, which shows up as a steep scarp, and the convex bank presents a long gentle profile. As concave bank is known as cut-off bank, which shows up as a steep scarp, and the convex bank represents a long gentle profile. क्योंकि यहाँ पर जो है देखो ये होगा कॉन्केव बैंक, तो यहाँ पर क्या होगा इरोशन होगा, और ये जो कॉन्वेक्स होगा तो वहाँ पर चीज़ें डिपॉजिट करेगा, ठीक है। ये कॉन्केव बैंक है और इधर से आपका उल्टा साइड में होगा आपका कॉन्वेक्स बैंक। दिखा नहीं गया यहाँ पर क्या कौन सी 6.7, यही जो 6.7 है भाई ये, ठीक है। As meanders grow into deep loops, the same may get cut off due to erosion at the inflection points and the left edge oxbow lakes. Now groundwater. So here the interest is not on groundwater as a resource. Our focus is on the work of groundwater in the erosion of land masses and evolution of landforms. The surface water, देखो यहाँ पर काफ़ी अच्छा दिखा गया, swallow hole in section, देन सिंक होल, तो स्वालो होल से सिंक होल कैसे बनता है, देन कोलाप्स ऑफ सिंक, सेक्शन ऑफ कोलाप्स सिंक, तो कोलाप्स हो जाता है फिर, और तो सरफेस में कैसे दिखता है एक्चुअल में ये ऐसा दिखता है, स्वालो होल से सिंक होल बन गया है, सिंक होल से जो है इसको जब मिल जाता है तब उसे उबालास बोलते हैं और वैली सिंक्स बोलता है, ठीक है। वेरियस कास्ट फीचर्स, तो ये सारे के बारे में हम पढ़ेंगे यहाँ पर। और यहाँ पर दिखाया गया देखो ऐसे बनता है स्टैलेक्टाइट स्टैलेक्टाइट, ये तो आपको पता है। केप माउथ है, पिलर है, केव है, ओके। तो पढ़ते हैं क्या पढ़ा, दी सरफेस वाटर percolates oil when the rocks are permeable, thinly bedded and highly jointed and cracked. After vertically going down to some depth, the water under the ground flows horizontally through the bedding planes, joints or through the materials themselves. It is this downward and horizontal movement of water which causes the rocks to erode. First downward and then horizontal movement of water which causes the rocks to erode. Physical or mechanical removal of materials by moving groundwater is insignificant in developing landforms, right? Physical or mechanical removal of materials by moving groundwater is insignificant in developing landforms. That is why the results of the work of groundwater cannot be seen in all types of rocks, but in rocks like limestones or dolomites rich in calcium carbonate. The surface water are as well as groundwater through the chemical processes of solution and precipitation deposition develop varieties of landforms. These two processes of solution and precipitation are active in limestones or dolomites, occurring either exclusively or interbedded with other rocks. Any limestone or dolomitic region showing typical landforms produced by the action of groundwater through the processes of solution and deposition is called karst topography. After the typical topography developed in limestone rocks of karst region in the Balkans adjacent to Adriatic Sea. तो ये karst topography क्या है, किस प्लेस का नाम था, एक रीजन का नाम था, तो वहाँ से वो टोपोग्राफी का नाम पड़ा है. द karst topography is also corrected by erosional and depositional landforms. So erosional landforms में क्या आता है, देखो पूल्स आता है, सिंक होल्स आता है, लैपीज आता है. तो याद रखना बहुत इंपॉर्टेंट बात है. लाइमस्टोन पेवमेंट्स आता है, ये सारे इरोशन के कारण बनता है. ठीक है, इरोशनल लैंडफॉर्म्स है ये, पूल्स, सिंक होल्स, लैपीज एंड पेवमेंट्स. लाइमस्टोन पेवमेंट्स, पूल्स, सिंक होल्स, लैपीज एंड पेवमेंट्स. Small to medium sized round to sub-rounded shallow depressions called swallow holes form on the surface of limestone through solution. Sinkholes are very common in limestone karst areas. A sinkhole is an opening more or less circular to the top and funnel shaped towards the bottom, with sizes varying in area from a few square meter to a hectare, and with depth form a less than half a meter to 30 meters or more. Some of these form solely through solution action, and others might start as solution forms first, and if the bottom of sinkhole forms the roof of a void or cave underground, it might collapse, leaving a large hole opening into a cave or a void below. That is collapsing. Quite often sinkholes are covered up with soil mantle and appear as shallow water pools. Anybody stepping over such pools would go down, like it happens in quicksands in deserts. The term doline is sometimes used to refer the collapsing. Okay, so collapsing को हम doline बोलते हैं. Solution sinks are more common than collapsings. Quite often the surface runoff simply goes down shallow and sink holes and flow as underground streams and re-emerge at a distance downstream through a cave opening. When sinkholes and dolines join together because of slumping of materials along their margins or due to roof collapse of caves, long, narrow to wide trenches called valley sinks or uvalas form. Gradually, most of the surface of the limestone is eaten away by these pits and trenches, leaving it extremely irregular with a maze of points, grooves and ridges or ledges. Especially these ridges or ledges form due to differential solution activity along parallel to subparallel joints. The ledge field may eventually turn into somewhat smooth limestone pavements. Caves in areas where there are alternating beds of rock, shells, sandstones, quartzites with limestones or dolomites in between, or in areas where limestones are dense, massive and occurring as thick beds, cave formation is prominent. Water percolates down either through the materials or through cracks and joints and moves horizontally along bedding planes. It is along these bedding planes that the limestone dissolves, and along the long and narrow to wide gaps called caves result. There can be a maze of caves at different elevations depending upon the limestone beds and intervening rocks. Caves normally have an opening through which cave streams are discharged. Caves having openings at both the ends are called tunnels. Now, depositional landforms forms develop within the limestone caves. The chief chemical in limestone is calcium carbonate, which is easily soluble in carbonated water. Carbon dioxide absorbed rainwater. This calcium carbonate is deposited when the water carrying it in solution evaporates or loses its carbon dioxide as it trickles over rough rock surfaces. तो स्टैलेक्टाइट, स्टैलेग्माइट्स एंड पिलर्स जो है डिपोजिशनल लैंडफॉर्म्स है. स्टैलेक्टाइट्स हैंग एज icicles of different diameters. Normally they are broad at their bases and tapered towards the free ends, showing up in a variety of forms. Stalagmites rise up from the floor of the caves. In fact, stalagmite form due to dripping water from the surface or through the thin pipe of the stalactite immediately below it. Stalagmite may take the shape of a column, a disc with either a smooth rounded bulging end or a miniature crater-like depression. The stalagmite and stalactites eventually fuse to give rise to columns and pillars of different diameters. तो यहाँ पर जो हमने देखा था, ये देखो, यहाँ पर ये तो स्टैलेग्माइट ग्राउंड से बनता है और स्टैलेक्टाइट वो हैंग करता है, ठीक है, तो हैंगिंग है। स्टैलेक्टाइट जो है हैंगिंग फ्रॉम द सीलिंग, एंड स्टैलेग्माइट जो है वो बिल्ड अप फ्रॉम द ग्राउंड, और जब जो दोनों मिल जाते हैं तब वो पिलर बन जाते हैं, तो डिपोजिशनल लैंडफॉर्म है। अब देखो ग्लेशियर्स हैं, तो ग्लेशियर्स में हम देखते हैं मासेस ऑफ आइस मूविंग एज सीट्स ओवर द लैंड, कॉन्टिनेंटल ग्लेशियर और पिडमॉन्ट ग्लेशियर, इफ ए वास्ट शीट ऑफ ice is spread over the plains at the foot of mountain or as linear flows down the slope of mountains in broad drop like valleys। तो माउंटेन में है तो माउंटेन ग्लेशियर बोलेंगे, अगर कॉन्टिनेंट है तो कॉन्टिनेंट ग्लेशियर बोलेंगे, अगर माउंटेन के नीचे है तो पिडमॉन्ट ग्लेशियर बोलेंगे। ये सारा चीज़ तो आपको पता होगा। Are called glaciers. The movement of glaciers is slow, unlike water flow. The movement could be a few centimeters to a few meters a day, or even less or more. Glaciers move basically because of the force of gravity. We have many glaciers in our country, moving down the slopes and valleys in Himalayas. Higher reaches of Uttarakhand, Himachal Pradesh, and Jammu and Kashmir are places to see some of them. Do you know where one can see river Bhagirathi is basically fed by meltwaters from under the snout Gamuk of the Gangotri glacier. In fact, Alakpuri glacier feeds waters up to Alaknanda river. Okay, Alakpuri glacier. Now, rivers Alaknanda and Bhagirathi join to make river Ganga near Devrayag. तो अलकपुरी ग्लेशियर, इसका एक नया इन्फॉर्मेशन आपको मिल सकता है, ये नया लग सकता है। अलकपुरी ग्लेशियर जो है अलकनंदा रिवर अलकपुरी ग्लेशियर से बनता है, originate होता है। Now erosion by glaciers is tremendous because of friction caused by shear weight of the ice. The material plucked from the land by glacier, usually large sized angular blocks and fragments, get dragged along the floors or sides of the valleys and cause great damage through abrasion and plucking. Glaciers can cause significant damage to even unweathered rocks and can reduce high amounts into low hills and plains. As glaciers continue to move, debris gets removed, divides get lowered, and eventually the slope is reduced to such an extent that glaciers will stop moving, leaving only a mass of low hills and vast outwash plains along with other depositional features. Glacial erosion and depositional forms described in the text. Okay, now erosional landforms. Sharks are the most common of landforms in glaciated mountains. These sharks quite often are found at the heads of glacial valleys. The accumulated ice guards these sharks while moving down the mountain tops. They are deep, long, and wide troughs or basins with very steep concave to vertically dropping high walls at its head as well as sides. A lake of water can be seen quite often within the sharks after the glacier disappears. Such lakes are called shark or torn lakes. There can be two or more sharks, one leading into another down below in a stepped sequence. Horns on serrated ridges. So horns form through headward erosion of the shark walls. If three or more radiating glaciers cut headward until their sharks meet, high, sharp pointed and steep-sided peaks called horns form. The divides between shark side walls or head walls get narrow because of progressive erosion and turn into serrated or sawtooth ridges, sometimes referred to as aritige, with very sharp crest and a zigzag outline. The highest peak in the Alps, Matterhorn, and the highest peak in the Himalayas, Everest, are in fact horns formed through headward erosion of radiating sharks. तो shark का horn का example क्या है? Matterhorn, highest peak of the Alps, and Everest of the Himalayas. डायग्राम काफ़ी क्लियर है, अच्छी है, देख सकते हो यहाँ पर दिखाया गया हॉर्न क्या है, कोल क्या है, एरिटी क्या है, शार्क क्या है, ठीक है। देन हैंगिंग वैली टैंक, सॉरी हम आगे जाके पढ़ेंगे, अभी काफ़ी अच्छी पिक्चर है ये। ओके, नाउ ग्लेशियल वैलीज और ट्रैप्स। Glaciated valleys are trough-like or U-shaped with broad floors and relatively smooth and steep sides. The valleys may contain littered debris or debris shaped as moraines with swampy appearance. There may be lakes gouged out of rocky floor or formed by debris within the valleys. There can be hanging valleys at an elevation on one or both sides of the main glacial valley. The faces of divides or spurs of such hanging valleys opening into main glacial valleys are quite often truncated to give them an appearance like triangular facets. Very deep glacial troughs filled with seawater and making up shorelines in high latitudes are called fjords. What are the basic differences between glacial valleys and river valleys? ओके, ये क्वेश्चन था, व्हाट आर दी डिफरेंस बिटवीन ग्लेशियल वैलीज एंड रिवर वैलीज। ठीक है, अब देखो डिपोजिशन लैंडफॉर्म्स दी अनएसॉर्टेड कोर्स एंड फाइन डेब्रिस ड्रॉप्ड बाय द मेल्टिंग ग्लेशियर इज कॉल्ड ग्लेशियल till. Most of the rock fragments in till are angular or to subangular in form. Streams form by melting ice at the bottom sides of lower ends of glacier. Some amount of rock debris small enough to be carried by such meltwater streams is washed down and deposited. Such glaciofluvial deposits are called outwash deposits. Unlike till deposits, the outwash deposits are roughly stratified and assorted. The rock fragments in outwash deposits are somewhat rounded at their edges. Figure 6.12 shows a few depositional landforms commonly found in glacial areas. Now moraines. They are long ridges of deposits of glacial till. Terminal moraines are long ridges of debris. यहाँ पर भी देखो कितनी अच्छी डायग्राम बहुत सुंदर दिया गया है यहाँ पर। ठीक है, तो जो ख़त्म हो जा रहा है सारी चीज़ें, तो वहाँ से जो है यहाँ पर जैसे था ना माउंटेन देखो ख़त्म हो गया, तो यहाँ पर हम आउट ऑफ प्लेन इसको बोल रहा है, वहाँ से चीज़ें आ रहा है। अरे कहाँ था आउट ऑफ डिपॉजिट। ठीक है, ग्लेशियर फ्लूवियल मतलब ग्लेशियल एंड फ्लूवियल दोनों का साथ मिलकर करना पड़ता है। ठीक है, दो एजेंट काम करता है यहाँ पर। ओके, अब देखो मोरेन्स क्या पढ़ रहे थे। दे आर लॉन्ग रीजेस ऑफ डिपोजिट्स ऑफ ग्लेशियर टिल। टर्मिनल मोरेन्स आर लॉन्ग रीजेस ऑफ डेब्रिस deposited at the end toe of the glacier. Lateral moraines form along the sides parallel to the glacial valleys. ये पिक्चर एक बार देख लो। आउटर्स प्लेन यहाँ पर दिखाया गया है। टर्मिनल मोरेन तो अभी पढ़ रहे हैं हम, आउटर्स है और ठीक है, बाकी फीचर्स हमने पढ़ नहीं है अभी, तो देखते हैं। ठीक है, चलो। lateral moraines form along the sides parallel to the glacial valleys. The lateral moraines may join a terminal moraine forming a horseshoe-shaped ridge. एंड 6.11 तो ये देख लेते हैं कि कैसे होता है 6.11 में। देखो lateral moraine join a terminal moraine by forming a horseshoe-shaped ridge। अच्छा, तो ये तो क्या हुआ ये? क्या बोला कि the lateral moraines may join a terminal moraine forming a horseshoe-shaped ridge. Okay, there can be many lateral moraines on either side in a glacial valley. These moraines partly or fully owe their origin to glaciofluvial waters pushing up materials to the sides of glaciers. Many valley glaciers retreating rapidly leave an irregular sheet of till over their valley floors. Such deposits varying greatly in thickness and in surface topography are called ground moraines. So the moraine in the center of the glacial valley flanked by lateral moraines is called medial moraine. Right, the moraine in the center of the glacial valley, then they are imperfectly formed as compared to lateral moraines. Sometimes medial moraines are indistinguishable from ground moraines. Now escarps. When glaciers melt in summer, the water flows on the surface of the ice or seeps down along the margins or even moves through holes in the ice. These waters accumulate beneath the glacier and flow like streams in a channel beneath the ice. Such streams flow over the ground, not in valley cut in the ground, with ice forming its banks. Very coarse materials like boulders and blocks along with some minor fractions of rock debris carried into the stream settle in the valley of ice beneath the glacier, and after the ice melts can be found as a sinus ridge called escarp. Outer plains, the plains at the foot of the glacial mountains or beyond the limits of continental ice sheets, are covered with glaciofluvial deposits in the form of broad flat alluvial plains which may join to form outer plains of gravel, silt, sand and clay. Now distinguish between river alluvial plains and glacial outwash plains. Now drumlins. Drumlins are smooth oval shaped ridge like features composed mainly of glacial till with some masses of gravel and sand. The long axes of drumlins are parallel to the direction of ice movement. They may measure up to 1 km in length and 30 meters or so in height. One end of the drumlins facing the glacier called the stosh end is blunter and steeper than the other end called tail. The drumlins form due to dumping of rock debris beneath heavily loaded ice through fissures in the glacier. The stosh end gets blunted due to pushing by moving ice. Drumlins give an indication of direction of glacier movement. What is the difference between till and alluvium? तो ये हो गया ग्लेशियर की मोटी मोटी बातें। यहाँ पर ज़्यादा कुछ मतलब डिटेल में चीज़ें नहीं हुई, बट जितना है काफ़ी है। आई थिंक इससे बाहर और डिटेल आपको पूछा नहीं जाएगा इस टीजीटी पीजीटी एग्ज़ाम में, तो ठीक है। अब चीज़ों को समझने के लिए आपको और भी चीज़ एक्सप्लोर कर सकते हैं, बट थोड़ा मेरे को बोरिंग लग रहा है इस चैप्टर, क्योंकि क्या है, उतना कुछ पढ़ने के लिए है नहीं। अब waves and currents. So coastal processes are the most dynamic and hence most destructive. So don't you think it is important to know about the coastal processes and forms? Some of the changes along the coast take place very fast. At one place there can be erosion in one season and deposition in another. Most of the changes along the coast are accomplished by waves. When waves break, the water is thrown with great force onto the shore, and simultaneously there is a great churning of sediments on the sea bottom. Constant impact of breaking waves drastically affects the coast. Storm waves and tsunami waves can cause far-reaching changes in short period of time than normal breaking waves. As wave environment changes, the intensity of the force of breaking waves changes. Do you know about the generating forces behind waves and currents? If not, refer to the chapter on movements in ocean waters. Other than the action of waves, the coastal landforms depend upon the configuration of land and sea floor, whether the coast is advancing, emerging, sheared, or retreating, submerging, landward. Assuming तो इमर्जिंग एंड सबमर्जिंग, ये देखो एक बार कोस्ट। Assuming sea level to be constant, two types of coast are considered to explain the concept of evolution of coast landforms: high rocky coast, that is submerged coast, and low, smooth and gentle sloping sedimentary coast, that is immersed coast. Now high rocky coast. Along the high rocky coast, the rivers appear to have been drawn with highly irregular coastline. The coastline appears highly indented with extension of water into the land where glacial valleys, fjords are present. The hillsides drop off sharply into the water. Shores do not show any depositional landforms initially. Erosion features dominate. Along high rocky coasts, waves break with great force against the land, shaping the hillsides into cliffs. With constant pounding by waves, the cliffs recede, leaving a wave-cut platform in front of the sea cliff. Waves gradually minimize the irregularities along the shore. The materials which fall off and removed from the sea cliffs gradually break into smaller fragments and roll to roundness will get deposited in the offshore. After a considerable period of cliff development and retreat, when coastline turns somewhat smooth, with the addition of some more material to this deposit in the offshore, a wave-built trace would develop in front of wave-cut trace. As the erosion along the coast takes place, a good supply material becomes available to longshore currents and waves to deposit them as beaches along the shore and as bars, long ridges of sand and or shingles parallel to the coast in the nearshore zone. Bars are submerged features, and when bars show up above water, they are called barrier bars. Barrier bar which get keyed up to the headland of a bay is called a spit. When barrier bars and spits form at the mouth of a bay and block it, a lagoon forms. तो देखो ये टर्म्स आपको समझना है और याद रखना है, ठीक है, बहुत इंपॉर्टेंट है ये। बैरियर बार्स क्या है, स्पीड क्या है, लेगून तो आपको पता है। और जो कंफ्यूजिंग टर्म्स है थोड़ा, द लेगून्स वुड ग्रेजुअली गेट फिल्ड अप बाय सेडिमेंट्स फ्रॉम द लैंड गिविंग राइज टू ए कोस्टल प्लेन। तो यहाँ पर इमेजेस नहीं दिया गया था, तो मैंने स्टॉलर की जो बुक है फिजिकल, वो हो सके तो वो भी मैं कवर करूँगा आगे जाकर डेफिनेटली। बीपीएससी और मेंस के एग्ज़ाम से पहले तो नहीं हो पाएगा, बाद में कभी करेंगे। तो वहाँ पर डायग्राम के थ्रू चीज़ों को बहुत सारे आसानी से एक्सप्लेन किया गया था, मैंने पढ़ा था एक बार, ठीक है। तो वहाँ पर चीज़ें हैं, तो काफ़ी बाद में शेयर करूँगा। अभी के लिए आप प्लीज़ एक बार इमेजेस को सर्च करके देख लेना कि बैरियर बार्स क्या होते हैं, स्पीड क्या है, तो आपको याद रहेगा, ठीक है। अब देखो लो सेडिमेंट्री कोस्ट। अलोंग लो सेडिमेंट्री कोस्ट द रिवर्स appear to extend their length by building coastal plains and deltas. The coastline appears smooth with occasional uh, incursions of water in the form of lagoons and tidal creeks. The land slopes gently into the water. Marshes and swamps may abound along the coast. Depositional features dominate. So when waves break over a gentle sloping sedimentary coast, the bottom sediments get churned and move readily, building bars, barrier bars, spits and lagoons. Lagoons would eventually turn into a swamp, which would subsequently turn into a coastal plain. The maintenance of these depositional features depends upon the steady supply of material. Storm and tsunami waves cause drastic changes irrespective of supply of sediments. Large rivers which bring lots of sediments build deltas along low sedimentary coasts. The west coast of our country is a high rocky retreating coast. Erosional forms dominate in the west coast. The east coast of India is a low sedimentary coast. Depositional forms dominate in the east coast. What are the various differences between a high rocky coast and a low sedimentary coast in terms of processes and landforms? Erosional landforms, cliffs, traces, caves, and stacks. Wave-cut cliffs and traces are two forms usually found where erosion is the dominant shear process. Almost all sea cliffs are steep and may range from a few meters to 30 meters or even more. At the foot of such cliffs there may be a flat or gently sloping platform covered by rock debris derived from the sea cliff behind. Such platforms occurring at elevations above the average height of waves is called a wave-cut trace. The lashing of waves against the base of the cliff and the rock debris that gets mashed against the cliff along with lashing waves creates hollows, and these hollows get widened and deepened to form sea caves. The roofs of caves collapse and the sea cliffs recede further inland. Retreat of the cliff may leave some remnants of rock standing isolated as small islands just off the shore. Such resistant masses of rock, originally parts of a cliff or hill, are called stacks, sea stacks. Like all other features, sea stacks are also temporary, and eventually coastal hills and cliffs will disappear because of wave erosion, giving rise to narrow coastal plains, and with one rush of deposits from over the land behind may get covered up by alluvium or may get covered up by shingle or sand to form a wide beach. Now, depositional landforms, beaches and dunes. Beaches are characteristics of shorelines that are dominated by deposition but may occur as patches along even the rugged surface shores. Most of the sediments making up the beaches comes from land carried by the streams and rivers or from wave erosion. Beaches are temporary features. The sandy beach, which appears so permanent, may be reduced to a very narrow strip of coarse pebble in some other decision. Most of the beaches are made up of sand-sized materials. Beaches called single beaches contain excessively small pebbles and even cobbles. Just behind the beach, the sands lifted and winnowed from the over the beach surfaces will be deposited as sand dunes. Sand dunes forming long ridges parallel to the coastline are very common along low sedimentary coast. Bars, variation speeds, so a ridge of sand and shingle formed in the sea in the offshore zone lying approximately parallel to the coast is called an offshore bar. An offshore bar which is exposed due to further addition of sand is termed as barrier bar. The offshore bars and barriers commonly form across the mouth of a river or at the entrance of a bay. Sometimes such barrier bars get keyed up to one end of the bay when they are called spits. वही सेम चीज़ रिपीट हो रहा है. Spits may also develop attached to headlands or hills. The barriers, bars and spits at the mouth of the bay gradually extend, leaving only a small opening of the bay into the sea, and the bay will eventually develop into a lagoon. The lagoons get filled up gradually by sediment coming from the land or from the beach itself aided by wind, and a broad and wide coastal plain may develop replacing a lagoon. अभी कितना है भाई? अभी विंड से तो यहाँ पर ख़त्म होता है. ठीक है, इसको ख़त्म कर लेते. थोड़ा क्या ना, वो थ्रॉट में थोड़ा कैसा कैसा लग रहा है, मतलब ठंड लगने से जैसा होता है ना वो वाला, तो इसलिए थोड़ा वॉइस डाउन हो गया. सॉरी फॉर दैट, बट इसको कंप्लीट कर ही लेते हैं. चलो. एंड डू यू नो द कोस्टल ऑफशोर बार्स ऑफर द फर्स्ट बफर or defense against storm or tsunami by absorbing most of their destructive force. Then come the barriers, beaches, beach dunes and mangroves, if any, to absorb the destructive force of storm or tsunami waves. So if you do anything which disturbs the sediment budget, his sediment budget, ये एक important term है, and the mangroves along the coast, these coastal forms will get eroded away, leaving human habitations to bear first strike of storm and tsunami waves. तो कोस्टल ऑफशोर बार्स जो है वो बहुत इंपॉर्टेंट है. फर्स्ट बफर एंड डिफेंस अगेंस्ट storm and tsunamis by absorbing most of their destructive force. Then come the barriers, beaches, beach dunes and mangroves. Now winds. So wind is one of the two dominant agents in hot deserts. The desert floors get heated up too much and too quickly because of being dry and barren. The heated floors heat up the air directly above them and result in upward movements in the hot lighter air with turbulence, and any obstructions in its path sets up eddies, winds, updrafts and downdrafts. Winds also moved along the desert floors with great speed, and the obstruction in their path create turbulence. Of course, there are storm winds which are very destructive. Winds cause depletion, abrasion, and impact. Depletion includes lifting and removal of dust and smaller particles from the surface of rocks. In the transportation process, sand and silt act as effective tools to abrade the land surface. The impact is simply shear force of momentum which occurs when sand is blown into or against a rock surface. It is similar to sand blasting operation. The wind action creates a number of interesting erosional and depositional features in the deserts. In fact, many features of deserts owe their formation to mass wasting and running water as seed floods. Though rain is scarce in deserts, it comes down torrentially in a short period of time. The desert rocks devoid of vegetation, exposed to mechanical and chemical weathering processes due to drastic diurnal temperature changes, decay faster, and the torrential rains help in removing the weathered materials easily. That means the weathered debris in deserts is moved by not only wind but also by rain or sea wash. The wind moves fine materials and general mass erosion is accomplished mainly through seed floods or seed wash. Stream channels in desert areas are broad, smooth, and indefinite and flow for a brief time after rains. Erosional landforms, pediments, and pediplans. Landscape evolution in deserts is primarily concerned with the formation and extension of pediments, gently inclined rocky floors close to the mountains at their foot with or without a thin cover of debris are called pediments. Such rocky floors form through the erosion of mountain front through a combination of lateral erosion by streams and sheet flooding. Erosion starts along the steep margins of the landmass or the steep sides of the tectonically controlled steep insertion features over the landmass. Once pediments are formed with a steep wash slope followed by cliff or free face above it, the steep wash slope and free face retreat backwards. This method of erosion is termed as parallel retreat of slopes through backwasting. So through parallel retreat of slopes, the pediments extend backwards at the expense of mountain front and gradually the mountain gets reduced, leaving an in-shell bulge. In-shell bulge, which is a remnant of the mountain. That's how the high relief in desert areas is reduced to low featureless plains called pediplains. प्लायज आर बाई फॉर द मोस्ट प्रोमिनेंट लैंडफॉर्म्स इन द डेजर्ट. तो प्लायज के साथ काफ़ी बार मैं कन्फ्यूज हो जाता हूँ कि इरोशनल कैसे हो गया, ठीक है, सॉरी डिपोजिशनल कैसे हो गया. हाँ, तो ये तो इरोशनल ही तो है. प्लेन्स आर by far the most prominent landforms in the deserts in basins with mountains and hills around and along. Drainage is towards the center of the basin, and due to gradual deposition of sediment from basin margins, a nearly level plain forms at the center of the basin. In times of sufficient water, this plain is covered up by a shallow water body. Such types of shallow lakes are called as plays, where water is retained only for short duration due to evaporation, and quite often the plays contain good deposition of salts. The plain covered up by salts and called alkali floods. तो क्या ना, एक बार आई थिंक AGC नेट का क्वेश्चन था, वहाँ पर डिपोजिशनल फीचर्स को आइडेंटिफाई करने के लिए बोला था, तो वहाँ पर लिस्ट में प्लायास भी शामिल था, तो इसीलिए. बट यहाँ पर तो देखो इरोशनल के अंदर ही प्लायास को रखा गया है ना, ठीक है. तो कि plains are by far the most prominent landforms in the deserts in basins with mountains and hills around and along. The drainage is towards the center of the basin, and due to gradual deposition of sediments from basin margins, in nearly level plain forms at the center of the basin. In times of sufficient water, this plain is covered. तो ये तो डिपोजिशनली हो रहा है ना प्लायाज, और इसको यहाँ पर इरोशनल क्यों रख दिया. मतलब प्लायाज जो होता है वो पानी आता है, ठीक है, वाटर आता है चारों तरफ से और वो जमता है किसी बेसिन में, पर वो जब इवापोरेट हो जाता है तो सॉल्ट रह जाता है. ऐसे सॉल्ट तो डिपोजिशन हो रहा है, तो एक दिन वो प्लाया भर जाएगा. इसको अल्कली फ्लैट बोलते हैं. पता नहीं फिर इसको इरोशन में क्यों डाल दिया. नाउ डिप्लेशन हॉलोजन केव. सो वेदर्ड मेंटल फ्रॉम over the rocks or bare soil gets blown out by persistent movement of wind currents in one direction. This process may create shallow depressions called depletion hollows. Depletion also creates numerous small pits or cavities over rock surfaces. The rock faces suffer impact and abrasion of wind-borne sand, and first shallow depressions called blowouts are created, and some of the blowouts become deeper and wider, fit to be called caves. mushroom table and pedestal rocks. So many rock outcrops in the desert easily susceptible to wind deflation and abrasion are worn out quickly, leaving some remnants of resistant rocks polished beautifully in the shape of mushroom with a slender stalk and a broad and rounded pear-shaped cap above. Sometimes the top surface is broad like a tabletop, and quite often the remnants stand out like pedestals. List the erosional features carved out by wind action and action of seed plants. So depositional landforms. Wind is a good sorting agent. Depending upon the velocity of wind, different sizes of grains are moved along the floors by rolling up or saltation and carried in suspension, and in this process of transportation itself the materials get sorted. When the wind slows or begins to die down, depending upon sizes of grains and other critical velocities, the grains will begin to settle. So in depositional landforms made by wind, good sorting of grains can be found, since wind is there everywhere, and wherever there is a good source of sand and with constant wind directions, depositional features in arid regions can develop anywhere. Now sand dunes. Dry hot deserts are good places for sand dune formation. Obstacles to initiate dune formation are equally important. There can be a great variety of dune forms. ओके तो ये ड्यून फॉर्म्स जो बहुत इंपॉर्टेंट है कि टाइप्स ऑफ ड्यून सैंड ड्यून से बारखान है, सीप है, पैराबोलिक है, ट्रांसवर्स, इसका कैरेक्टरिस्टिक्स क्या है, लैंड लॉन्गिट्यूडनल क्या है, ये पढ़ना है आपको. Now crescent shaped dunes called barkhans with the points or wings directed out from wind direction, that is downward from where the wind direction is constant and moderate, and where the original surface over which sand is moving is almost uniform. Parabolic dunes form when sandy surfaces are partially covered with vegetation. That means parabolic dunes are reversed barkhans with wind direction being the same. Sheep is similar to barkhan with a small difference. Sheep has only one wing up or point. This happens when there is a shift in wind conditions. The long wings of ships can grow very long and high. Longitudinal dunes form when supply of sand is poor and wind direction is constant. They appear as long ridges of considerable length but low in height. Transverse dunes are aligned perpendicular to wind direction. These winds form when the wind direction is constant and the source of sand is an elongated feature at right angles to the wind direction. They may be very long and low in height. When sand is plenty, quite often the irregular shaped dunes coalesce and lose their individual characteristics. Most of the dunes in the desert shift, and a few of them will get stabilized, especially near human habitation. तो एक बार ये जो है पिक्चर को देखो, लॉन्गिट्यूडनल ऐसे होता है, ट्रांसवर्स जो है परपेंडिकुलर होता है, ठीक है. तो इस ट्रांसवर्स ड्यून है देखो, लॉन्गिट्यूडनल होता है, ये लॉन्गिट्यूडनल ड्यून सब बारखान. शिप्स जो है इसका एक ही होता है, और पैराबोलिक है उल्टा हो जाता है ये, ठीक है, बारखान का उल्टा होगा पैराबोलिक ड्यून्स. और एक था शिप ट्रांसवर्स पैराबोलिक ड्यून्स form when sandy surfaces are partially covered with vegetation. So that means parabolic dunes are reversed barkhans when wind direction being the same. And then हाँ, तो बेसिकली इतने ही है ना, इतना ही है. तब इसको याद रखिए, ठीक है. कैरेक्टरिस्टिक्स को और भी पढ़िए और ट्राई करते हैं हम भी पढ़ने का, और अगर मैंने पढ़ा तो डेफिनेटली आपके साथ शेयर होगा. तो ये बात है. तो चलिए इस वीडियो को यहीं पे स्टॉप करते हैं, ठीक है. और हमने 6 चैप्टर तक पढ़ ली है अब, और आई थिंक 5 चैप्टर्स है, यूनिट 4 हम चले आए. तो यहाँ से हम अगले वीडियोज़ में कंटिन्यू करेंगे. थैंक यू फ्रेंड्स.